So yeah, hello everyone. This is my first live stream of YouTube. So in these live streams, basically I'll be just solving problems and telling the intuition behind that. And yeah, we will keep it pretty much simple for this first stream because it is my first time. So I'll not be going. I'll not be solving many problems, maybe 3 or 4 problems, but we will be like going deep into the problems, like how to solve that particular problem, how do you recognize that pattern, and so on and so forth. We'll be discussing each and everything. So yeah, I hope you will enjoy that. Uh, Many of you were asking that why I have stopped like uploading the daily challenges videos, like on LinkedIn, on YouTube, my previous videos. Many of you have commented and messaged me on LinkedIn like please start making DSA challenge videos again. So yeah, I also wanted to make that, but yeah, like I was also working on my some personal projects, so I need to take time for that as well, so that's why I skipped that for now. But yeah, like we can go on with the daily live streaming as well. I can't guarantee daily, but yeah, obviously, like maybe Thursday, Friday, or like Friday, Saturday, and Sunday, we can obviously do that. And maybe in some weekdays as well, 1 or 2 days, I can obviously give time for this as well. So yeah, why not do this live stream? Try to do this live stream daily. I'll try my best to do this daily, but yeah, 3 days will be like obviously for sure there will be the live streams, and we'll be solving problems, discussing the doubts, and all of that thing. So I hope you enjoy those things. Let me see if the chat is there or not. Hmm. Let me just check if everything is working fine or not. Okay, it is running. Let me just check on the YouTube as well. Check if everything is working fine or not. Sorry, I was on mute at all this time. So anyways, let me just check on the YouTube as well. Okay, the health is excellent. Analytics, stream. Yeah, so let me just check with my phone as well, because it is my first live stream, so I don't know how everything will work out. So anyways, let me just check it with my phone as well. Okay, the health is excellent. Analytics, stream. Yeah, so let me just check with my phone as well, because it is my first live stream, so I don't know how everything will work out. So anyways, let me just check it with my phone as well. Yeah. Okay, the health is excellent. So I wasn't on mute. My mic was working. It was the let me just volume that I have, because it is my first live stream, so I don't know how everything will work out. Anyways, let me just check it with my viewers are there. Okay, analytics, current. Okay, the health is excellent. So I wasn't on mute. My mic was working. It was the no problem volume that I can, because it is my first live stream, so I don't know start with the live always work out. Yeah, before starting on to the live stream, let me just check. I have launched my website as well. So let me just give the website. I wasn't chat box so that you can go and it was use the problem. It is basically for the pattern wise DSA problem. So I don't know started the website where before starting on DSA live stream, I have created I have launched my website. So you can go to the website, solve problems, discuss with the community, mark for revision, track the progress that you can. On top of that, there is one more thing that is it is basically for the pattern wise profile revision. So I also had a feature of free profile revision. So I have used LeetCode profile for review. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do of course. So I will be doing the review problems, discuss with the community, mark for revision, track the progress that giving you a proper documentation. There is one more thing that it is basically for the pattern wise profile revision. So I also had a feature of free profile revision by moving forward. I will for the next step. So you can do you have any doubt, it is just for Java and Python for writing and yeah, I'll give you some Okay, so I think it is clear now. So actually this was already muted, so I by mistake just turned on that, so that's why the issue was there. So I think it is fixed now. Can you just check it? So I think it is clear now. So actually this was already muted, so I by mistake just turned on that, so that's why the issue was there. So I think it is fixed now. Can you yeah, I think it is fixed now. Hmm. Just yeah. So we can just start with the problem solving thing. So what problem we can take? We will pick like mediums only for now. 3 to 4 problems, medium or one easy as well. For today we will just keep it very simple. Yeah, we will also solve hard and like very hard problems as well, but yeah, for now, for today, for the first time, let us just keep it simple. So what problem to choose? Maybe this permutation thing. Let me just open live chat as well so that I can see the chat as well. Maybe this permutation thing. Let me just open live chat as well so that I can see the chat as well. So yeah, if you have any questions, you can write it in the live chat. I'll be answering. So yeah, someone has asked, where are you working right now? So I am currently in Ahmedabad. I am working at Hyperlink Infosystem as a full stack developer. If you have any other questions, you can write it in the chat related to problems as well. I'll be happy to answer that. So what problem to choose? Let us take this one, group anagrams. I've already solved like around majority of the problems, not majority, but yeah, around 1300 or so. So yeah, I'll be just explaining those. Because I already know the solutions, and because I have practiced a lot of problems of on these kinds of like LeetCode problems. So yeah, mm, this is just the, what you can say, an explanation kind of live stream where I'll be telling you my thought process, my approach, and how to look at the patterns and all of that. So yeah, let us start with the discussion. So it is the problem named group anagrams. So you are given an array of string strs. Now you need to group the anagrams together, so you can return the answer in any order. Now what is anagram? Anagrams is a word or a phrase formed by rearranging the letters of different words using all the original letters exactly once. So what does this particular thing mean? What does this anagram mean? So anagram simply means that if you have been provided with some particular word, let's say EAT, and you have been provided with TEA, so you need to check whether this is an anagram or not. So first you need to know what is anagram. So anagram basically means that whether you can rearrange these words in some way that you can convert this EAT to TEA or vice versa, TEA to EAT. So all those words that are formed by only these three characters along with their frequency count as well. It is not that you can use T more than once or anything like that. If T is used once, you need to use once only. If T is used twice, you need to use twice only. So all those combinations, after trying all those combinations, whatever words that you can create are a set of anagram for those characters. So for example, with E, A and T, what all you can create? EAT itself, TEA itself, ETA itself, like there will be many combinations, right? So all these will be the combinations. All these combinations of word will be known as anagram, because you can see all the characters are same which is used in EAT, just we have changed their places, nothing else. So this is what anagram means. So in this, what we need to return right now, we need to return like we need to return all the groups of anagrams. So for example, let us see this first example in which the string input string is given as a like EAT, TEA, TAN, ATE, NAT and BAT. So you can see the answer is this. So how did they arrive at the answer? So if you look at this output, this particular output, let me just copy that and paste it here. So you can see BAT is the single word, that means there is no other word such as TAB or ATB or like BTA, anything like that. There is no other word like that in this input, so that's why this BAT is alone. Now if you look at this second group of anagram is what? NAT and TAN. So you can see there are two words, TAN and NAT. So you can see that if you rearrange NAT in just reverse order, you will get TAN. So you can see that here also T is used one number of time, A is used one number of time, and N is also used one number of time. And here also you can see T, A and N, all three are used only one number of time. So that means you can say that we have used this frequency exactly as required, and no other extra character or one or any lesser character is used. if there are three characters, we have used three characters only, and also we are matching the frequency. So these conditions say that these two are a set of anagrams. Now you can say that NAT is anagram of TAN, or vice versa. You can also say TAN is anagram of NAT. So that's why these are put together as a single anagram, as a single group of anagram. If you see the next group is ATE, EAT, and TEA. Now again in this particular input, you can see that you have been provided with EAT, TEA, and ATE. Now here the three distinct characters are E, A, and T. So we just need to check whether uh, all these three words are formed by these characters only, along with their frequency, such that this is also one, this is also one, and this is also one. So you can see that ATE, A is used one number of time, T is also used one number of time, and E is also used one number of time. Same here and same in this case. So that's why we can say this is a single or a one particular group of anagram. So that is how it will be followed, and you can see why this is the answer. Now we know the answer, let us see the constraints. So constraints are 10 raised to the power 4 and STRS of a particular word's length can be up to 100 digits, not digits, 100 characters, and this entire input array can go up to 10 raised to the power 4. So these are the constraints. So first of all, how we can say that these two particular words are anagram or not? So let me just see chat also side by side if anything is coming or not. Yeah, if you have any doubts you can write in the chat as well. So yeah, where were we? Yeah, so we were discussing that how we can say that okay, these two characters are anagram. We have understood, but what is the logic behind it? How we will implement that? How we can say that okay, TEA and EAT are anagrams? We can't like actually compare all the characters and all of that. This thing will give us time limit exceeded errors. So what we can do? If you observe something, let's say these three words EAT, TEA, and what was that? ATE, 8. What if you sort these characters? If you sort these words, you will get here EAT, oh sorry, ATE, AET, sorry, my bad. Here also you will get AET, and here also you will get AET. So after sorting, EAT will become AET, TEA will also become AET, and ATE will also become AET. So you see, this is how we can identify which all words belong to one particular group of anagram. These three were one particular group of anagram, so their sorted word, when we sort their characters in increasing order, that sorted word, those will be same. If you didn't understand, let us take another example, NAT and TAN. So NAT and TAN. So you can see NAT, what is the sorted order? A and T, and here also it will be A and T. So you see the sorted order is same. So if the sorted order is exactly same, that means all the characters whose sorted order is A and T, those all words will belong to the same anagram. So this is the idea behind how we will find whether a particular word will belong to this particular group of anagram or not. So yeah, if you have any doubts you can just write it in the chat. Let me just check the chat as well. Yeah. Yeah. So no questions till now. Okay. So once we have identified the group, then it is just easy. So side by side, I can just also code as well so that it will be easier. But before that, one thing we need to understand: if we have ATE, EAT, and TEA, now their sorted order is AET. Here also AET, and here also AET. Now, did you observe something here? These are can't like there is some observation in this. What is that observation? These can be like grouped as a key value pair. The anagram, the sorted order can be a key, because we know that okay, these three words belong to one particular anagram, but how will we group them? We can just get the sorted order. So will we iterate again and again to the entire array? That will again give us time limit exceeded error. So how will we group them? We know that sorted orders, all those words that will have the same sorted order will be in the same anagram, but how will we group them? How will we say that okay, this is AET, this is AET, and this is AET, so their corresponding actual word should belong to the same group? How will we group them? So you can see that we can create a map where this sorted order will be the key, and we can take an array or vector as these words. So ATE will be there, EAT will be there, and TEA will be there. Same for this particular NATTAN. So its actual sorted order was A and T. So this will be the key. And what will be the anagrams? Actual anagrams will be NAT and TAN. So this is how we will proceed. So what we will do, we will first find their sorted orders and store it in the unordered map. And then what we can do, for each and every word we will do this. For each and every word we will iterate. We will just take that particular word, we will sort it, we will put it into our map, and after the map we will also push it inside our this particular array thing. And then in the end we can just return each and every array by just iterating over each and every key that we have. So I hope you understand till now. If you have any doubts, you can write it in the chat. So yeah. So someone has written in the chat something. Let me just check. Yeah, hello. Bite me. Yeah, hello. Oh, sorry. This was my alternate account. What is this? I cannot understand. Yeah, if you have any doubts, you can write. Otherwise, we can just move forward with the code. Yeah, so till now, no doubts. Yeah, so we can just write the code now. So we can just take n as the input of the strings that we have. So n is strs dot size. Now what we need to do, we need to have an unordered map with key as any string, and its corresponding value will be vector of string. So unordered map. Now why unordered map? Why not ordered map? Because here we do not need to do anything with the order. We just need to return the answer in any order. So you can see that we can return answer in any order. If there would be some specific order given, and even if it was not given, and by logically we need to return in some particular order, then we would be using ordered map. Otherwise, always use unordered map, because its time complexity is lesser than the ordered map. So yeah, we will discuss in much detail in some other, maybe I will create some videos on C++ STLs, But yeah, for now we can just proceed with this particular problem. So unordered map of what will be the first one, the string, and the second, the key will be string, and the what you can say, value will be vector of string or array of string. In my case I always prefer vectors, so I'll be taking vector of string. And yeah, we can give it a name as MP. Now what we need to do, now we need to group these anagrams together. So for example, EAT, its sorted order will be AET. So AET will be one key, and corresponding to that we will store EAT. Then comes TEA, its sorted order will be AET. So AET is already present, so no big deal, it will always be pointing to that AET only. So in front of AET we'll be storing TEA. So this is how we'll be proceeding forward. So we can just iterate on this entire strings vector of strings. So int I equal to 0, I less than n, I plus plus. What we need to do, we need to sort. So sort, what we need to sort, strs of I dot begin strs, or like simply we can just create a variable, let's say string key, which is nothing but strs of I, and we just need to sort that particular key. So sort key dot begin key dot end. Yeah, so we have now this key in sorted order, so we now need to push it like insert it inside our unordered map. So MP of key, what will be equal to, not equal to, because it is vector of string, so it will be pushback. So dot pushback what, this strs of I, strs of I. So what happened here, let's say the strs of I was what was the first one, EAT. So let's say first strs of I is EAT, so here we will be getting EAT. Now this is not the actual key will now become sorted. So after sorting it will become something like this, AET, and AET will be pushed inside a map. So what happens here, AET will point to what, this strs of I. So this strs of I is pointed by AET, not only strs of I, this particular strs of I, maybe in future some more elements will come, it will be pushed inside this particular array. So here it will be what, EAT. So this is how scenario looks like. Now some other character comes, let's say now T comes, TEA. So here the key will be what, TEA. Again the sorted order will be AET only. So now AET will point to EAT comma TEA. So this is how things will move forward. Now if you want to see how this particular map looks, I can just print it out for you. So for auto IT over MP, let me just check if there is anything. Oh no. So yeah, we can just print it and the entire thing, it dot first will be what, it will be the key, the sorted order. So yeah, we can just like say this is the first one, and corresponding to that we will be having all those words that are present, like EAT, TEA and all of that. So what we can do, instead of this we can do something like this, we can make it a pointer, and we can again run a loop for let's say I over IT, and or rather just we can run normal for loop for int j equal to 0, j less than IT dot second, because IT dot second is an array. So IT dot second dot size j plus plus. So we can just print out these things as well. See out what we need to print out. I think there is something wrong. Yeah. Oh, sorry, I have written this particular thing in a wrong way. We can just print like it.second as well. Let's see. For now, we will just return an empty thing, or rather empty like this. Anything new? No. Yeah, we cannot print like this, obviously. For now, what we can do, the key is the it.second, so we need to loop on the it.second. For what we can write, for auto j over it.second, we can just see out j. We can do like this, not c put, c out. So is it fine now? For it is over mp it.first, it.second, for j over it.second, c out j. Maybe we can write something like this. So yeah, you can see yeah, for first BAT we have the sorted order as ABT, and then its corresponding actual word is BAT. For that TAN and NAT we have already discussed, and for EAT and all of that also. So A and T is like TAN and NAT, and for EAT, T and ATE we have AET, and yeah, these are the three corresponding words. So this is one group of anagram, this is one group of anagram, and this is one group of anagram. So I don't know, like I think I have written the sorted order wrong while explaining, but yeah, spare me for that. This is my first live stream, so I am also pretty nervous. So yeah, anyways, this is what how it actually looks. So now what we need to do, let us again visualize through this particular example only. What we need to do, for every corresponding key we just need to take its vector, right? Because that is what it is written. The first is BAT, so the first is BAT. The second is NAT and TAN, so we can take TAN and NAT. The order doesn't matter, they are already mentioned. The third one is ATE, EAT and TAA. So third one is AET, EAT and TEA. So what we need to do, for every key we just need to take the entire array and push it into our result. So what we can do from now, we can create a vector of string result. Now at each and every index one group of anagram will be there. So at first at 0th index this bat array will be there, at first index this tan array will be there, and at the second index this eat array will be there. So this is how we need to do. So what we can do, we can iterate over this it of MP, and like for this particular it, whatever it.second is there, so we just need to push that. So result dot push back it.second, and yeah, we are good to go. And instead of returning this thing, we can just return result. So anything new? So yeah, it gives us the correct answer. You can see for the first one we got bat, for the second one we got sorry, this is our output, this is the expected. So first one we got bat, the second one we got tan and nat, and for the third one eat, t and 8. Now you might say that, oh, this order differs, but order doesn't matter because the problem statement has already said you can return answer in any order. So it runs on the example test case, so let us just submit it. So let me just side by side see the chat as well if anything has come. So yeah, we can just submit it. Yeah, so it got accepted. So this is how will be we actually solve this particular problem. So I hope you understand this particular problem. If you have any doubts, you can write it in the chat section. I'll be there to answer. So for, let's say, for next 5 to 10 minutes, let us just see the chat only if anyone writes anything related to this particular problem. So yeah, for this particular question, I don't see anything in the chat. So we can just move on to the next problem, or let us find out what we can choose the next problem. I have actually before the live stream started, I was actually thinking to take one of the DP problems because like we can go much inside DP for one particular problem as well, and there are many things that we can learn from a single DP problem. Like there are various concepts like why a particular problem greedy thing does not work, why only DP works, uh, in what scenarios greedy will actually work and DP will not work, sorry, DP will also work. So what all cases can be there, how we can think. Now if greedy fails, then DP will occur, then we will solve it by DP. Now how will we proceed with the DP? We have states, we have transitions. So how these states are defined, how we decide the dimensions of the DP, there are a lot of things to cover. Why how we can think that this particular problem can be solved actually by DP or not, how we can look at the constraints and get some idea, how with the help of problem statement we can get the idea that okay, this can be solved using DP. So with a lot of practice, you will be able to understand the some kinds of patterns. I have solved around like 200 DP problems only, so like I have already captured those things. So you can visit my website. I have just like step by step problems I have mentioned. So if you solve one problem, the next problem will be just little bit variation of that. So you can just visit my website. Once again, some promotion thing. So yeah, uh, so there are various things to learn in DP, and one of my favorite DP problems that like I explain to each and every person who asks me to give a guidance on DP. I suggest him to solve this one particular problem, not because of just that it is a very popular DP problem, but it is not actually how we look at this problem. Let me just show you. This problem is edit distance. So let us solve this edit distance problem only. So this edit distance is, you known this problem by a LeetCode problem, but this is not actually a lead code problem. It is actually a lead code problem, but this is not the origin of this problem. This particular problem is actually an algorithm which is just the problem statement which is given. So how you solve this problem, what is this problem statement, this entire thing is actually an algorithm. So by way we solve this particular problem, this entire thing is actually an algorithm which is made by Levenstein. So if you search Levenstein distance algorithm, I have actually made a project on this particular uh, algorithm. So that's when I came to know that okay, this thing is little bit reminding of me some DP problem. So I got to know this particular thing and I was like very surprised. So if you see the mathematical formula behind this, you can see lev of I comma j, lev of I minus 1 comma j plus 1. We will see this exact notation how we can write in this DP part. We will see step by step how this entire mathematical thing is actually working. So step by step we'll be solving. So these things really fascinate like personally me to look into more other things rather than just solving this particular problem. So I always like what you can say, try to see the real world examples as well. And I suggest to you guys as well, if you learn DSA, just don't learn for the sake of interviews. I have never learned DSA just for sake of cracking interviews. I genuinely love solving DSA problems, and I generally look various aspects rather than just solving that particular problem, how it can be real implemented in the real world, how it is useful in the real world. So many things like that. So if you see problems in that way, you'll be able to uh, have more interest in DSA as well. Let me just check the chat as well. Yeah, nothing in the chat. Yeah, you can write in the chat as well if you have something to ask me, like I can help you guys. So yeah, nothing in the chat till now. So yeah, we can just move forward with the problem. So like, let me just reset this. I have solved this problem like few days ago only. What is this? Okay. So edit distance. Given two strings, word 1 and word 2, return the minimum number of operations required to convert word 1 to word 2. Now you can perform the following three operations permitted on particular word 1. You can either insert a character, you can delete a character, or you can replace a character. So what does this mean? So let us see this particular example. So I hope you understand this problem. So you just need to convert word 1 to word 2 by performing only these three operations any number of times. So you can either perform insert a character, you can insert a particular character in any position, you can delete a particular character, or you can just replace a particular character with some any other character. And you need to do these operations as minimum times as possible, and you need to convert word 1 to word 2. So in minimum operations you need to convert word 1 to word 2. This is the summary of the problem. So let us see this first example. So the first word is horse and the second word is Ross. So you need to convert horse to ROS. So let us go with the explanation how they have explained. Then we will see how we can do this particular thing, how we can build our logic. In this question also you can think like in the greedy way as well. I will take that example from my side as well. Like how we can do it in a greedy way, but greedy will fail. How the local optimal choice will not be the global optimal choice. So we will see the greedy part as well. So you can see they have said that first replace H with R. So okay, we replaced H with R, so it will become H RORSE, and this will be remaining. Obviously this will be same, so it will be ROS. Now we came across this word O, so here also it is O and here also it is O. So there is one, like, keep one thing in your mind, that if something is same, if something doesn't actually require an operation, so don't do any operation. Obviously if two characters are same, so why will you perform any operations, why will you insert anything, why will you delete anything, right? So if two characters are same, just move forward. So here also it is O and here also it is O, so you just move forward. Now it is R and now it is S. So what you can do, they have said remove R. So remove R. Now in this case you could try out some other possibilities as well. You can have various other ways to get to this particular word ROS, but what is the minimum, that is the question. So according to them we need to remove R. So what will happen if we remove R? If we remove R, it will be remain RO and then it will be SE, and here it will be remaining same, it will be ROS. Now you can see first one is same R, second one is same OO, and third one is also same S and S. Now there is only one thing, E. Here we don't have anything. So in this case there can be two scenarios. I'll discuss the first one, that is the current case. If you have some letters, let's say 1 2 3 4 5 6, and you need to convert it into this particular number of words. Now the destination string has only 4 characters, and your your original string has 6 characters. So can you think by replacing or inserting you can remove these 2 characters? No. If your original length is greater than the destination string's length, then obviously you need to remove some characters. So this is the first case. You need to delete some characters. So delete some characters. So this is one case. What can be the other way around? Other way around can be like, just take the opposite of that. Here you have 4 characters and here you have let's say 6 characters. So here you need to fill 2 places, right? Here you need to have one more dash, then only your length will become equal. Forget about the characters, first your length should be equal, right? If you are saying we need to convert one word to another word, then obviously first you will think that okay, we need to make their length same. So by deletion or replacing any character won't help you in getting the length equal in this case. In this case, what operation will help? Insertion. So in these two scenarios you always require delete operation, and in this case you always require insertion operation, that is for sure. So this is one thing that we need to keep this thing in our mind. So this is the same scenario, the first one. Here you have one extra character and here you don't have any character, so you just remove this character ROS. Now everything is same. So how many operations required? So actually here it was E, so ROS, and here also it is ROS. So now they both become equal. So how many operations? 1 operation, 2 operation, 3 operation. So the output is 3. So this is how we get to the output. So this is how we got the minimum number of operations. Now let us take this particular example, or let us forget about this example, because we just need to this is nothing more like unique example than this example. we can just move on to the next part, that is why greedy will not work here. Now you will always think that okay, if two characters are not equal, we can always replace the character. If here like what was that case in which we removed, yeah, in this case we removed r, this particular r. So why can't we just replace it with s? So here s will be there and here also s will be there. It will not work. Let me give you one example. In this case I haven't tried, in this case it might work, might not work, I don't know, but let us take one example. Let's say GEEK, or let this is the destination word. Now here it is GENEK. Now here the two characters till now are equal, so you won't perform any operation. But now here you said okay, here it is N, here it is E, so simply replace. That's what greedy says. Replace every character. Don't need to perform insertion deletion, just replace the character with the destination character. So now you replace it with E. So now you see okay, here it is E and here sorry for that, here also it is E. So we are good to go, right? But the next two characters are not same. So here you need to convert it this to K. So now this will become equal, and now you need to remove this last character K. So in total you performed 3 operations. So by greedy way, this was the greedy way, you performed 3 operations. But is it the actual optimal answer? No, it is not. Let me tell you why. This is Janek and this is Geek. Now instead of replacing this N with E, you can just delete this N. Now you see one thing, this became equal. So with just one operation, we made source string to the destination string. So that is why greedy failed here. Why? Because greedy didn't think what could be the future possibilities. Greedy just thought okay, just replace here, replace N with E, it will be equal, but it didn't take care of the future scenarios, what this particular operation would do in the future circumstances. Here with the help of recursion, initially we will solve this particular problem with recursion. With recursion we will try out all possible scenarios. We will try to do insert operation, we will try to do delete operation, and we will try to do replace operation. So we will check each and every possible scenario, and whichever possible scenario gives us the minimum answer, we will just return that. So let me just check the chat as well. So nothing here. You guys are shy or what? You're not asking anything. You can write your doubts here in the chat section. So yeah, we can just move forward. So we can try out all the possible scenarios. Now one thing I need to mention here by inserting or deleting or replacing, we will not actually perform these operations. We will just increment our operation. Let me show you. We will just play with the pointers. You can, if you want, you can insert it, delete it, I don't know, you can try it out. But the way I learned, you can just do everything with the help of pointers. So let us take this particular example, horse and what was that, ROS. So here the first one was replace H with R. So H with R. So by replacing, we will not actually replace this particular character, we will keep the strings as it is. What we can do, the first one, the pointer will be here, the I pointer, and for this one the J pointer will be pointing to R. So here I pointer is pointing to H, J pointer is pointing to R. So you see H and R are not matching. So you see, you first try out maybe insert operation, delete operation, now you come at replace operation. So now you actually won't replace this H with R. What you can do, what will actually happen when you replace that first, that think that first. So if you replace this r and r will become equal, right? So you will move on to the next character. So now your I pointer will move to O, and your J pointer will also move to O. So what happened actually by replace operation? Actually nothing internally changed. You just move your I pointer and J pointer one step ahead. So what actually happened in the replace operation? Let me just write these notes as well. In replace operation, I also moved one step forward, and J also moved one step forward. So even if you just keep this H as it is, if you internally you think, okay, we need to perform replace operation, but what will that replace operation do? It will move I pointer one step ahead and move J pointer one step ahead. It will not do anything more. So even if you do not perform any operations, if you just move your pointers ahead, this will be same thing. So this is what I like. This is the main thing also in this particular problem. So let us see some another scenario. Let's say some what was that, a remove operation, let's say. So remove was performed in ROR SE. So here it will be converted to ROSE. So here it was ROS. Now we need to remove this R. So what happens? So currently our I pointer is at here at R, and our J pointer is at S. So you deleted this R, right? So what actually happened when you deleted this R? So you deleted this R, that means this character no more exists. So what happened? Your pointer point now to S, which is the next character. So when you deleted this R, instead of deleting it, you just point your I pointer to next, and J will remain as it is because this particular character got deleted. Now you still need to compare the next two characters. So in replace, you incremented both I and J pointers. In delete, what you can do, you can just increment your I pointer and your J will remain same. If you didn't understand, you can just like skip at one step backwards or dry run in your notebook. You will understand this is very basic thing. Like instead of removing this particular character, just move your one step pointer ahead. That will be same thing. Your pointer scenario will be same at the moment. So instead of deleting, we are just moving the pointers ahead. Same way for the insertion. So insertion, it will be vice versa. So let's say if we inserted one character here, so R is here, so let's say we inserted, let's say E. So now what will happen? No, not this example. Let's say some another example we take. Here we have A, B, C, D, E, and here we have A, B, C, D, E, F, E, F. So here our I pointer is at C, and J pointer is also at C. So we inserted the character. So in this case, our J pointer will move forward. Why J pointer will move forward? Because not C here, we can change it to D. So if you are at here D, you said okay, here it is C, here it is D, so I want to insert C in between. So you inserted C. Now you can see C and C are same, right? So your I pointer will remain same, but your J pointer will now move forward to compare the next character, because obviously your C was already matching. So what you did in this particular replace, since both the characters got matched at the same indexes, so you move both the pointers ahead. In this particular delete part, you deleted the character, so the position shifted, and in this the position shifted in this backward direction, so you shifted your I pointer at +1 step. In this in this particular delete operation, insert operation, your position shifted to the rightwards. So here you will, if you will now increment I +1, it will be 2 step lagging. So instead of incrementing I pointer, you need to increment your J pointer to here. So this is how it will be moving forward. I hope you understand. Let me just check the chat now. So if you have any doubts till now, you can write it in the chat. Let me just drink some water. Actually, this is my first live stream, so I didn't actually thought it will last even 1 hour long. But yeah, it's actually good. You can discuss anything with me in the chat. I'm just taking 5 to 10 minutes of break, and then we will continue. Anything related to like some projects, DSA, anything. So no questions till now, so yeah, we can just move forward. mm, so we have discussed the replace thing. If two characters are sorry for that, if two characters are same, so we just sorry, if two characters are not same, so we try to replace it. So if we replace this, now these two characters became same, so both move pointers move ahead. In case of insert, uh, what I have done, yeah, in case of insert, uh, if these two characters are not same, we try to insert one character. So if we insert one character, this will move one step ahead. So now we don't want to compare these two characters because we have inserted the same character. So now we need to compare one step ahead with the current j pointer. So we move I plus 1. So in this, where I have written this, I think I have written something wrong. Sorry for that. Actually, in insert, if we are like inserting HORSC and ROS, so if we insert here S, so now we need to compare S and S are same. Now we need to compare this R with S, right? So we will move I plus 1. So I think I have told previously wrong, or I don't know, like I'm pretty much nervous today, so sorry for that. In the delete, it is pretty much opposite. If you have R and if you delete that particular sorry, not R, let's say here it is R and O, okay, so now you deleted this particular thing O, so now you need to check like what, let me just check with the example. I just lost it for a while now. If you insert with the character, okay, so here it was ROS, here it was R. So in insert it will work fine because you have inserted S, so now it will be working fine. S and S are equal. Is it S? Sorry, we haven't performed the correct operation, right? We do not need to first. Oh, sorry, I have taken the wrong example with wrong, wrong operation. Sorry, here it was remove, not insert. So HORSC and here it is ROS. So replace, we have already seen, it is clear, I plus 1 J plus 1, and here it is HORSC. Now we will remove R, so first it will be RORSC. Here we will be at this particular R, and here will be at A. So if we remove, yes, we will remove, right? If we will remove, so it will be S. Now we need to compare, that R got removed, that means now these two characters will be matching, so we just need to move our I pointer one step ahead to compare it with what, yeah, it was R. Let me just pinpoint with the pointers as well so that it is much clear. Here it is at R, here it is at S. So R and S are not equal, so you thought to delete this particular thing, right? So if you delete it, your pointer will remain same at R because you actually didn't delete it. So you need to put your I pointer to the next forward. So you move I plus 1 to one step ahead. So this is the delete operation. So you do what? I plus 1 and j remains same, and replace will happen, reverse will happen in the insert operation. So let us take one example, insert. So actually previously I have taken wrong, I have taken some like example by myself, but instead of delete operation I have done insert operation. So sorry for that misclarification. uh, yeah, and when I took this example I actually was inserting r in between, but I need to remove r, so that's why I just got confused with the pointers. Anyways, yeah, here it is. Let's say insert, right? So here it is EXECTION, and here it is EXECUTION, execution. Now he's saying to insert u. So where we need to insert u? Execute. So here. So at this moment C is same. So here T, our pointer will be actually at T here, right? So 1 2 3 4 and 5 here, right? And here it will be at U. So you see, C, it up till C everything is matching. Now we are at T and we are at U. So T and U are not matching, so we insert U in between. So now what will happen? Here it will be inserted U and U match, but you know what? Sorry, here it will be U. Yeah, I have written correctly. So here it is U. Now we need to point here. Now U and U are matching. Now you need to like serve the next character. So to serve the next character, you need to move your J pointer one step ahead. So you move the J pointer one step ahead. So this is how it will be done. So it was in case of delete, and now in case of insert it will be just I comma j plus 1. So hope everything is clear till now. In the chat, let's see. Nothing in the chat till now. Okay, anyways, so I hope you cleared this, you got cleared this much thing. So we can now first write the recursive code and then move on to the DP part. So yeah, we can just first write recursive code. So in recursive code we just rely on one base function that we call, or the one function that we call, that is solve. Let's say return, we will be returning this solve function that will give us the minimum operation. Before that we need to take the length of this particular two words, word1 dot size and m2 is word2 dot size. Now in this case, solve it will be. Now here what we need to pass, first we need to pass these two words, word1 word2, and along with their lengths. Now everything will be revolving around pointers, so I and j pointer we need to pass, but we will not pass actually the I variable and j variable. Instead we will pass a static value, that is 0 and 0, because initially both the pointers will be pointing to the first character. 0 comma 0 will be passed on, and then yeah, till now it will be this much only. If we will add dp, obviously we will add dp, so we will add a dp vector here also, but for now we are just looking at the recursion, so we are good to go till now. Now we will write this solve function. So it will return an integer value which will be the minimum distance value, and what will be inside this solve function? First we will be taking this string and word1 string, and have I written correctly? Yes, word2. Along with that we need to take their length int n and int m along with pointer I comma int j. Yeah, so first we will write the base conditions. So what was the base condition? The base condition I told was the thing that you need to delete some characters if one particular pointer has reached, if the j pointer has reached end of the string, and you need to insert the characters if I pointer has reached the end of the string. In both the cases we don't need to actually insert or delete, we just need to play with the pointers. So if let's say I has reached to the end of the string, this will be the case in this one, not this. Yes, if I has reached equal to n, that means he has passed all the string. Sorry, this case, if I is here, I will be here, so he has covered all the string. Now he need to insert characters. So how many characters he need to insert? 2 characters. But how will we calculate these 2 characters? J will be here, so total length minus j, sorry, j will not be here, j will be here because I has crossed n minus 1, so I will be at n and j will be here. So total length of this entire string is, let's say, what is the total length? 1 2 3 4 5 6 minus what is the position of j? J was here, so 0 1 2 3 4, because indexing happens in happens on 0 base. 6 minus 4, that gives us 2. So that means you need to insert 2 characters, that are these 2 characters. So what you will do, if I has reached the end of the string, that means you need to return you need to insert m minus j characters, or you need to say, we can say you need to perform m minus j operations. So return m minus j. So this will be the case, and vice versa will be case for the deletion. So if j is reached the end of the string, so it will be returning what? N minus I. These were the base cases. Now we need to perform operations, but before that we have also seen one scenario which we actually forgot because we have discussed very less on that particular case. That was if the 2 characters are matching. We have already discussed, but we haven't given a lot of thinking into that. So if the 2 words are equal, so let's say word 1 of I is equal to word 2 of j, then in that case, if these 2 are already equal, then we do not need to perform any operations. We can just move the string forward. So by moving forward, what do I mean? By moving I plus 1 and moving j plus 1. This is what we will do, because what we were doing here, if this O and O are equal, so what we were doing? We were doing nothing. We are just moving with the next character, R and S. So yes, yeah, so we are just moving with the I and j pointer ahead. So what we will do, we will return solve, we will write it inside this. We will pass word 1, we will pass word 2, we will pass m comma n comma m comma I plus 1 comma j plus 1. So this is how we will be doing. Now we need to perform 3 operations. In whatever operation we which gives us the minimum answer, we will take that. So we will return solve, sorry, it was solve. So minimum we need to take, so minimum of 3 operations, so minimum of 3 operations, so that's why we need to write curly braces. So 3 solve functions will be called, one for the insertion part, one for the deletion part, and one for the replace part. And whatever operation we do, we will add plus 1 because they all will contribute plus 1 operation to our answer. So plus 1. Now in the insert and delete, we already know we will move, in one case we will move I plus 1, and in the other case we will move j plus 1. So we can just copy this entire thing. In one we will move I plus 1 comma j, and in the other one we will move what? I comma j plus 1. And in the other, these the remaining one, the replace one, we will just move both the pointers ahead, I plus 1 comma j plus 1. So you might think like, what is the difference? Here also we are doing I plus 1 j plus 1, here also we are doing I plus 1 j plus 1. No, here the both characters were equal, so we did not need to perform any operation. So we just returned solve as it is with no addition. But here we have we need to perform one operation, that is replace operation. So we are not just returning solve function, we are adding +1 to it, because replace will take +1 operation to it. So that is what we are doing. So let us just remove all these things so that we can just see. It will give us TLE obviously. We are just building up our solution, recursion, then memoization. So I hope this will work. Let us see, submit it. This will not work, but yeah, the test cases work fine, but on submit it will give us time limit exceeded. So anything in the chat? No. Yeah, so obviously it will give us time limit exceeded. Why? Because you can see the word length is 500. So this solution is not feasible. So what we can do now, why this is not feasible? Because for every particular step we are checking 3 operations. So in total what will be the time complexity? Time complexity will be 3 to the power of n, and n is what? 500. So if you do 3 to the power 500, it will exceed 10 raised to the power 8, the limit that you have for the TLE. So that's why we cannot perform this particular method, that means recursion. So now we need to convert it to DP. So we will make a DP table. DP is nothing, recursion, whatever recursion is doing, store it in one memory. If any sub problem occurs, you just take it from the DP table instead of solving it again. That is the DP, nothing else. So we will create a 2D DP. Why? Because there are two states changing, I pointer and j pointer. So if two states are changing, we need to take 2D DP. So vector of int dp n comma vector of int m comma -1. Yeah, and we will pass DP table here, and here also we need to take DP as the parameter, vector of int and DP. Now everywhere, now here also we need to check if DP of I comma j is not equal to -1. That means we have already solved this particular sub problem, so just return DP of I comma j. Yes, otherwise just get us the answer and solve it in the DP table. So just solve and store it in our answer. Here also DP of I comma j equal to this. So I think this will work fine. Now let us run on example test cases. It is giving us error, solve function call to okay. We need to pass here also DP. We need to pass here also DP here as well, and DP here as well. So now submit, run. Yeah, now it gives us the correct answer, and if we submit it will get accepted. So yeah, it got accepted. So I hope you learned from this particular problem. If you have any doubt, you can ask it in the chat. I am just checking the chat now for a while, and then we'll be moving on to maybe next problem, or we'll just skip it for now or leave it for now, whatever you say. So it is already 1 hour and 30 minutes in the entire stream. So should we move forward with the next problem, or just we can quit now? So because just one email submission was wrong, I missed my opportunity of TCS NQT. Don't worry, you'll get much more higher opportunities moving forward. I don't know the process of TCS NQT, so I can't comment. So Krishna Jain is saying hard question. This is my first stream. Yeah, I will do hard problems as well, but this is my very first stream, so I'm very I'm pretty much nervous in this, so I didn't pick any hard problem. But yeah, from the next stream I will definitely try out the hard problems as well. So this was my first stream, so I'm just like it is just kind of a warm up for me. HD Gamers has said this TCS NQT opportunity. So don't worry, you will get much more opportunities in the future. I don't know the exact process of TCS NQT, but yeah, don't worry. You will get a better job. Mm, it's already 1 hour 30 minutes, so if I take another problem, another medium, it will take around 40 to 30 to 40 minutes actually, so it will be 2 hour long. So let us just end this particular session, and from the next sessions I will pick hard problems as well. So yeah, thank you for watching this live stream. Thank you. Bye.